Hello, and this time we're talking about Sec, Cosec and Cot, and these are trigonometric functions. You have hopefully heard of sin x, cos x and tan x. If you haven't, then this video probably isn't for you. But if you are familiar with these and you need to know about sec, cosec and cot, then this is what they are. So hopefully you know that sin x is opposite over hypotenuse, and this is adjacent over hypotenuse, and this is opposite over adjacent. And these are the three pairs that you can do, but you can also have them the other way around. So you could have hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite, and these have names as well. We'll do cos first. This one is called secant x, or just sec x, and the sign when it's turned around the other way is called cosecant x, or cosec x, and it's sometimes written CSC for cosec, just so it matches the 3-digit thing, and then cot x for cotangent of x, and these are simply just the ratios upside down. So these equal 1 over sin x, 1 over cos x, and 1 over tan x. And it's really easy to remember which one's which because you just look at the third digit. So cosec is sine, sec is cos, and cot is tan. Okay, so it's really quite straightforward which one's which, and that's literally all they are. They're just 1 over. Now, if you're asked to find out what a solution is, then you can just rewrite it and calculate it, okay, in the normal way. Your calculator probably doesn't have cosec, sec, and cot buttons, so you have to work out what it would be rearranged. So if someone says to you that cot x equals 12, and what's the value of x, you'd have to rewrite that as 1 over tan x equals 12, and therefore tan x equals 1 over 12, and then you can solve it in the normal way. We are going to go shift tan of 1 over 12. Okay, so, and there's your answer, 4.76. So it's just the same sort of idea of solving trigonometry, but you've got this extra layer where you have to rearrange in order to solve the equation. Okay, so these functions are defined just as this reciprocal nature. Don't get confused with sine to the -1 of x, which is the inverse x. So you see that on the calculator, sine to the -1. That's the inverse of sine, whereas sine x to the power of -1 means 1 over sine x, and that is going to be cosec x. And I think that's why we use them as functions, so that we don't get confused between the -1s for inverse and -1s for reciprocals. We can just use the different word, and then everyone knows that means 1 over sine, 1 over cos, or 1 over tan. The other thing you can do is when you're referring to the inverse, you can say arc sine x, and that is the inverse. That's equivalent of saying sine to the -1 of x. They mean the same thing, but we'll talk about that in a different video. Just so that you know that what these things mean is not the inverse like this, but 1 over. And here we are at everyone's favourite graphical calculator, Desmos, and I just want to show you what the graphs of these functions are. So here's sine x, we should know. Now this is doing it in radians, which is why it's crossing through at 3 and a bit there, which is obviously pi, and 6 and a bit there, which is 2 pi. But this is still true in degrees. I just couldn't be bothered to change the scale and change how it calculates and all that kind of stuff. We may as well be in radians. If you don't know what radians are, don't worry, it just means that the scale is slightly different on the x-axis, but the shape is still the same. Okay, so remember what we're doing is we're doing 1 over the function. So if I show you this is sine, so the corresponding 1 over sine, looks like this. Now this kind of makes sense if you think about it. Firstly, it's a repeating function and goes on forever, just like sine does. And if you think about each of the points, 1 over 1 is 1. And then as you get further away, 1 over a really small decimal is going to get bigger and bigger. And it's going to get bigger and bigger and bigger until you get 1 over 0, which is then, well, it's not infinity, but that's what we sort of say, isn't it? It's undefined. So this is asymptoting up there. And likewise here, as this approaches 0 here, then this curve is approaching there. So these asymptotes exist here at, oh, I can't draw on that. They exist here at 0, and then this is either pi in radians or is 180 in degrees, and then at 360 and at minus 180 and minus 360 and so on and so forth. Now cos being very similar, of course cos is just shifted along, then sec is also the exact same thing, just shifted along, and it does exactly the same thing, exact same shape, it's just moved in the exact same way that cos moves across from sine, so does sec from cosec, and we just get the asymptotes at 90 and at 270 degrees, or pi over 2 and 3 pi over 2. Funny one is tangent, so if we turn those off and put tangent up, then we can think about it in the same way. The zeros, 1 over 0 is going to be an asymptote there, and then we've got 1 over infinity, and that's, well, what's that going to be? Well, I think it's going to give us 0, although that's, I'm not entirely convinced that that's a logical way of thinking about it. But anyway, let's have a look at what it looks like. So yes, so where we have a 0 here, it's becoming an infinity. We have this sort of, it's almost like a, it's like it's been mirrored, but it's been mirrored and translated. It's been sort of flipped vertically and shifted across. So we've got, yeah, that infinity where it was 0, so that asymptote, and then it comes through, it meets where at 1, because 1 divided by 1 doesn't change, and then it hits the axis where the asymptote was for the original tan, and then it goes shooting down and asymptotes where this one, excuse me, hits 0. Now it is important that you know what those shapes look like, because you might get questions where it says things like sketch, you know, the graph of cot 3x or something like that, or cot 3x plus 2, and so you can do the same transformations of graphs as you would normally. You've got to know what the shape should be like, and then you would think, okay, well 3x, that's going to make it stretch in the, actually it's going to make it stretch in the x-axis, so it's going to shrink it in from left to right, make it more narrow, because it's, if the x is on, if the 3 is on the x, it happens first, so it's going to shrink everything in, make it a third of the width, and then plusing 2 is going to shift everything up. So let's just do that just to see what it looks like. Put a 3 in, we get more lines, and then if we add 2, then it just shifts everything up higher than it was by 2. So it's exactly the same as sketching graphs was before, you just have to know that those are the shapes of the graphs. Sine becoming cosec, cos becoming sec, and tan becoming cot, and we'll get rid of the exciting bits so it's back to normal cot. And then it's just a case of sketching things as per usual. And if you wanted to find out values where they hit axes and where they intersected with line, oh, can't draw on this, but if there was a straight line going through here and where does it intersect, then you'd do exactly the same as normal, make them equal, solve it, and process it from there. So I'll leave that there for this video. I will do other videos, but this one's getting a bit long now, about using these Sec Cosec and Cot. Hopefully you have an idea of what they are now and what these words represent. They simply mean this 1 over, this reciprocal relationship with sine, cos and tangent. Okay, but if you have any questions, then you can put them in the comments below. But for now, cheerio.